Hello everyone, welcome to our channel Only Physics JEE Grad. Today we are going to discuss JEE Advanced PYQs, PYQs from the chapter Electrostatics. This is going to be third part of our this video. In the last video, we have discussed the topic electric field, flux, Gauss law, and its application. So there were I've told you 42 questions, and we were discussed 24. So we are left with our 18th question, 18 questions. So we'll be discussing those in this video. So let us start. So this will be our first question. It's a pretty dangerous question, I must say. Okay. So this is a dangerous question. Let's start. Okay, perfect. So it's a tough question, but like you can solve it from two methods. So one is an easy way, and another is a integration method. So we'll solve it using both. So in this question, there is an infinite wire, as you can see, and it is at a distance root 3 by 2a from the y-axis. Okay. And what else is given? So we have to find the flux due to this wire through this plane. Okay, so let me make a diagram for you guys. So it's like this. So we have a plane like this. Okay, let me make axis like this. So if I say this is a center of this. Okay, so this is our first axis. This is our second axis, right? And this will be our third axis, right? And this is our wire. This is our wire. Okay. It has a charge density of lambda. Now, so for the first method, so method one will be solving it using integration. Okay. So by integration. So look, this is a plate and it's a finite length plate. Okay. So we have to use the basic method of flux, which we call integral E dot dA, right? So we have to take an integrating element whose area is dA, and we have to write electric field there, and then we have to integrate it. So let's start. So look, this length is A. So this length is A, and this length is L. Okay. Now let us take an integrating element from this. So this is our y-axis, right? This is our z-axis, and this is our x-axis. So let's take an integrating element in xy plane like this. So at a length x, I will be taking an integrating element like this. So are you with me, right? You're getting me how I'm taking an integrating element. So this is our whole plate. So we are taking a strip of it whose length is actually L, but width is dx. Right? Perfect. Now we have to find the electric field at this uh, strip. So it will be like this. Let me make a diagram. So look, so from here, right, at every point it will be like this. So wait, just give me a second. So I'm mentioning 3 points here. So this is our P point. Let's say this is our Q and this is our R, right? So at P, look, we have to make a straight line first. So this line is directly perpendicular on this Y, right? And electric field will be like, so uh, so this is our line, okay, which is directly on this, and the electric field will be at P point will be like this. Okay, are you getting me? And this is our line. So this is a triangle it is. So similarly at Q will be like this, will be like this. So at Q will make a straight line, a perpendicular on Y, then the electric field will be like this. Right? Are you getting me? Are you with me, everyone? So this is X. And this is we have given. So this length is how much? This length is root 3 by 2. Okay? So let's say this is an angle theta. So, and now look, the area vector at P must be downward, must be downward. So area vector will be like this. So this is area vector and this is electric field in red. Okay. Similarly, this is electric field and area vector will be in the downward direction. D. Right? Are you getting me? So let me delete this, and delete this. So this is length L. Yes, perfect. So let me draw this triangle, these triangles again. So we have this line, which is root 3 by 2a, and we have electric field in this direction at this. So area, this is our area, which is in this direction dA, and electric field in this direction, right? So if this is an angle theta, this will be also theta, and this is our x, right? Perfect. So let's solve this. Let's solve this. So flux will be, yes, what will the electric field? So if this is, so let's say this length is d, right? So d will be under root 3 by 4a square plus x square, right? So what will be the electric field? You know, due to infinite wire, so this is our wire, it is going inside the plane, okay? So it will be 2k lambda by d, right? Times, so we can write this area vector as L into dx. So L into dx, right? Into cos theta. So what will be the cos theta? Cos theta will be root 3 by 2a root, and this is d. So let me just write it as a d. So we will get flux will be 2k lambda L by dx will be as it is, and cos theta will be root 3 by 2a into d, and d was there, right? Perfect. So we'll get flux. Those terms which are constant, we can take it outside. So it will be 2k lambda L, and root and 2 will get cancelled. So we'll just left with root 3, right? So we will be left with root 3 k lambda L and A. And this will be dx divided by d square. So d square will be simply x square plus 3 by 4a square, right? Or simply we can write it as root 3 by 2a whole square. Okay. Now limit will be from, so this whole is a, so limit will be from minus a by 2 to plus a by 2, right? So we'll put the limit as minus a by 2 to plus a by 2, right? Now we have to solve. We know the integration of this. Integration of x square by x dx divided by x square plus a square. It will be 1 by a. Yes. So dx x square plus a square. We got 1 by a, tan inverse x by a, right? So root 3 k lambda a to 1 by a. So 1 by root 3 a by root 3 a by 2 to tan inverse x upon root 3 a by 2, right? And we have to put the limit here, minus a by 2 to plus a by 2. Okay, right? Okay, perfect. So root 3a will get cancelled and 2 will come up. So 2k lambda L, and this will be tan inverse a by 2. So a by 2 will cancel. So 1 by root 3 minus, and this will be plus tan inverse 1 by root 3, right? So we'll get what? So 2k lambda L, this will be twice of tan inverse 1 by root 3. So it will be 2 into pi by 6, right? 30 degree. So we will cancel this, it's 3. Now k we can write it as 2 into 1 upon 4 pi epsilon naught lambda L into pi by 3, right? So this will be 2, pi will get cancelled, so we'll get lambda L by 6 epsilon naught. And if we compare with this, so we will get n as 6. So we will get n as 6, right? So this is a pretty nice method to solve these type of question. This is of course 3D, so we have to solve like this. Okay. Now there is a second method which is comparatively easy. So let's solve with that. So method 2 is by Gauss theorem. Okay, so Gauss law. Let's start. So I have to make the diagram again. Uh, okay, let's make the diagram. So this was our plane. Let's say this was our center. So this is our one axis. This is our second axis, and this is our third axis, right? Perfect. And this was our wire. This is our wire. This was our y, was x, and this was z, right? Now let's use the Gauss theorem here. So I'm making a cylinder around this, which passes through the corners of these. Okay, so let me make the cylinder. Okay, right? And this cylinder is of course symmetrical. So our wire is passing through the center of this. Okay, so these are the center point of the uh, this cylinder. Okay, so cylinder will complete like this. Yes, are you getting this cylinder? Now look, this distance, this is our, this distance is our A, right? This was A, and this was L. Okay. Now look, so if I draw this cylinder like this, right? Now our wire is going like this, and this is the black portion. This was our green, right? Like this. Okay? Red. Red was red. Perfect. So this was our cylinder. This is the wire going inside the plane, and this is the part of our plane, right? So if I can just find this angle, if I just find this angle, then we can solve for like 360 for you by using unitary method. For 360 it will be q upon epsilon naught. So for this angle it will be like this, right? Let's solve. Perfect. So if this whole was a, so it will be a by 2, and this will be a by 2, right? And what is this length? So this length, let me write it in green. So this length, right? So this length was root 3 by 2a, right? So this length is root 3 by 2a. So if I say this is a theta, so we'll write sine theta as a tan theta, sorry, it will be tan theta, right? So it will be tan theta a by 2 by root 3 by 2a, right? So we'll get 1 by root 3. So we will get theta as 30 degree, which is pi by 6. So the whole angle will be this whole angle. So 2 theta will be 60 degrees, which is pi by 3, right? Now, let's use the unitary method. So for 2 pi, the flux will be equals to so sorry. So for 2 pi, the flux will be Q enclosed. So Q enclosed will be how much? So it will be lambda into L. So lambda into L divided by epsilon naught. Q enclosed upon epsilon naught, right? For pi by 3, it will be the required flux will be lambda L upon epsilon naught divided by 2 pi into pi by 3, right? Simple. So we will get lambda L upon 6 epsilon naught. So similarly, we'll get exact same answer as n by 6, right? So these two methods are pretty common. This method I like personally because it will give me the exact expression. This method is applicable here, but it might not applicable in the other cases. Okay, so be careful, right? So this is a hard question, of course, but with the second method, this becomes quite easy. Okay, so let's move on to a second question. So this is our second question. What we have here is an infinite solid cylinder of radius r has a uniform volumetric charge density rho. It has a cavity inside of radius r by 2, the center the same. Okay, the magnitude of electric field at point P, which is at a distance 2r from the axis of is given by this. Okay, so look, we have to subtract. Let's first find the electric field at P due to this cylinder. Okay, and we'll subtract the electric field due to this cavity. Now here we have a cylinder. Okay, so at a distance 2r, at a distance 2r, we'll make a Gaussian surface like this. Okay, right? So let's say it has a height h and radius of course 2r. So we'll write flux will be Q enclosed upon epsilon naught. Flux will be E. Now area will be curved surface, so it will be 2 pi 2r into h. Now Q enclosed. So Q enclosed will be, we have to take this r, right? So it will be rho pi r square h, right? There is no charge. The charge is in this cylinder itself, okay? In this cylinder itself, divided by epsilon naught. So let's cancel some things. H will get cancelled, pi will get cancelled, and we get 1 r will get cancelled. So left with electric field, 4 will come in the denominator. So will be rho r upon 4 epsilon naught, right? Now from this, we have to subtract the electric field due to this cavity. So let's find the electric field due to cavity. So E due to cavity will be, it will be simply K Q by 2R square, right? So K will be 1 upon 4 pi epsilon naught. Q will be rho into 4 upon 3 pi R by 2 cube divided by 4R square, right? So let's cancel things. 4 pi will get cancelled, and this will be rho by 3 epsilon naught, and it is 4r square, and this will be r cube by 8, right? So we'll have r left. So electric field due to cavity, and this is electric field due to cylinder, right? So electric field due to cavity will be rho r upon, so 4 into 24 epsilon naught, right? Perfect. So we have to subtract it. So E at P point will be E due to cylinder minus E due to cavity. Simple. So will be rho R by 4 epsilon naught will be common. So it will be 1 minus 1 upon 24, right? So we will get 23 rho R upon 24 into 4 epsilon naught. So if I take 4 common, so we'll get the rho 23 rho R upon 16 into, so 8 uh 6 will left, right? Yes, so 24 4 ja, it will be 96, and this will be 96, so right. So k will be 6. Okay, so it's an easy question, it's nothing to worry, but mistakes can happen. Okay, mistake can happen, like here you may write in a hurry like pi 2r square h, so it will be wrong, right? So there are these mistakes you should avoid. Perfect. Let's move on to our third question. Perfect. Okay. So we have here a nuclear charge ZE is non-uniformly distributed within a nucleus of radius r. So we have this nucleus, it has a radius r, and total charge is ZE. Okay, it is uniformly distributed. The charge density is dependent only on radial distance r from the center as shown in this figure. Okay, so this is not a figure, this is actually graph between r and density, right? So it will be constant till a, and then it decreases till capital R. Okay, and this is d. The electric field is only along the radial direction. Okay, so it is always along the radial direction. Now the electric field at r equal to r, so at r equal to r, it will be what? If I make this Gaussian surface, so we will be having flux equal to q total ZE upon epsilon naught. Flux will be E 4 pi r square, ZE by epsilon naught. So we'll get electric field at ZE on 4 pi epsilon naught r square, right? It will be like the sphere. So what saying independent of A? Yes, definitely it will be independent of A. Okay. Now, fourth question of this, if A is 0, the value of D will be. Okay. So how will we find this if A is 0? So we have to find the value of D, right? So we have to solve the density itself. Okay, let's solve it. So let's find the total charge, okay? So total charge will be integration of rho into dV, right? Perfect. So can we find it from here? No, we have to, right, we have to integrate. Okay, perfect. So let's first write the equation of this line, okay? Now this point is A comma D and this point is R comma 0. So if we can write it here, it will be rho, right? The slope will be this is D by this is R minus A. So it will be minus D upon R minus A into X minus R, right? Right? Perfect. So we will have this. So let's just put it here. Let's put it here. So we will get this is a generalized expression, right? This is a generalized expression. So we will have total charge. Okay, look, the total charge will not be this. Why? Because this will only gives the charge from A to R. We have to add this charge also. So this charge will be what? So density is this common, it is D. So we have to add. So let me write like this. So we have a density, okay, which is D into 4 by 3 pi A cube, right? Plus we will have integration rho into dV from A to capital R. Okay, perfect. So we will have, I'm generalizing things, so we'll just put the values and we'll get the answer. So QT will be D 4 by 3 pi A cube plus density will be, let's just put these things here, D by R minus A into X minus R into dV. So dV will be what? So if I take at X distance a sphere of thickness dx, right? So the dx. So volume will be 4 pi x square dx. Simple. Okay. Now let's just solve here. So the limit will be from A to R. Okay. Right. So I'll solve qt will be 4 by 3 pi a cube into d plus so this is minus d upon r minus a into 4 pi. We're left with x cube minus rx square to dx from a to r. Right? I'm just generalizing things. So we'll get qt 4 by 3 pi a cube into d minus 4 pi d upon r minus a, and we'll get x to the power 4 by 4 minus r x to the cube by 3 from a to r. Now in the question it is given if a is 0. So let's put a 0. So we'll get qt, total charge will be this 0 and this is 0. So we'll have minus 4 pi d by r. This is 0, so we'll just have to put r. So it will be r4 by 4 minus r4 by 3, right? And we know total charge is what? ZE. Okay, so we will get ZE as minus 4 pi d by r. We will left with minus r4 by 12. We'll just take this LCM. So this is 3, right? So what we have to find? D. So D we have to find. So D will be, this is R cube, this is minus minus B plus. So D will be 3ZE by pi R cube, pi R cube, right? Okay. So B will be the option, right? Now let's move on to fifth question of this same question. Now, the electric field within the nucleus is generally observed to be linearly dependent on R, right? So we have studied this. If we have a sphere, if we have sphere, and it electric field is directly proportional to R internally for R less than capital R, right? And we know this, it is rho R upon 3 epsilon naught, right? And when this happens, when this is uniformly charged, when this is uniformly charged, right? When this is uniformly charged, right? So what we'll get? Yes. So if density become constant, right? Uniformly charged, that means density becomes constant, right? And density is constant till R equals to A. But I need the density to be constant for the whole sphere. So A must be equals to R. So A must be equal to R, right? So this is an easy question. So if A is equals to R, our density will be constant D, and this formula will be valid, right? So this is a simple question, of course, but you have to be careful, okay? Now let's move on to our sixth question, shall we? So sixth question. So this is our sixth question. Right. So here we have two large circular discs separated by a distance this, okay? Charge oil of density this. So density of oil is 900 kg per meter cube are released to the center of this. Once the oil drops achieve terminal velocity, the switch is closed to apply 200-volt across the disc. Okay. As a result, oil drop of radius, so radius is given 18 to 10 raised to power minus 7 meter, stops moving vertically. So it stop. So there must be net force 0. Floats between the disk. So initially we have mg must be equal to 6 pi eta rv. Then the same mg must be equal to, so if it stop there will be no viscous force, so mg will be equal to q into e simply, right? Now buoyancy is not given, we have radius and density, we can find mass, g is given, electric field. Okay, so this we do not need this, not needed. Okay, let's just use this. So we will have density as rho 4 by 3 pi r cube to g will be q. Now electric field we have voltage of 200, so it will be v by d. So distance between them is 0.01. Let's just put the values here. So just write Q as rho naught into 0.01 into 4 upon 3 pi r cube divided by V and multiply G. Right. So we just have to solve this. It's a easy one. So it's a 900 into 0.01 into 4 by 3 into 22 by 7 we can write. Okay, no issues. R cube. So it will be 8 into 8 into 8 into 10 is power minus 7 into 3. It will be minus 21. G we can take 10. And voltage is 200, right? Perfect. Okay. So we have these 2 0 will get cancelled from this 1 0 also, and this 1 0 from here. Okay. Mm, we can cancel this too. So it will be 2, right? So what we have here is 10 raised to power minus 21. Okay. So what do we have to find? Number of electrons. So we can write Q as n into 1.6 into 10 raised to power minus 19, right? So we'll be having 9 into 22 into 8 to the power cube divided by 21. So this is 21, right? So it will be 10 raised to power minus 2. So we'll get n as, if I divide it, so it will be 9 into 22 into 8 to the power cube divided by 21 into 1.6 into 10 raised to power minus 2. Now just let me use the calculator really fast. So we have 9 into 22 into 8 cube, right? Divided by 21 divided by 1.6, right? So we have nothing is left, right? 2 is also left. 2 is left, right? 9, 22, and 2 is also left. We are left with 2, right? So 2 multiply by, right? So let me just calculate it again. 9 into 22 into 8 cube into 2 divided by 21 and divided by 1.6, right? So we will get, so we have 6,000 approx into 10 is over minus 2. So it will be 60. The answer is 6. There must be some mistake. Let me check really fast. Okay, so density is 900. We have put 9,000. So 10 will be less. So it will be 10 will be less. So 6, right? So this won't come. Right. So 6 will be the answer. Okay. So it's an easy question. Nothing to worry. Just this is an extra information which is given. You don't have to worry about it. Okay, perfect. Let's move on to our next question. Seventh. Right. Okay, perfect. So we have a disk whose surface charge density is given rho. It is not constant, it is changing rho naught 1 minus r by capital R. Perfect. Electric flux through a large spherical surface that encloses the charged disk completely is phi naught. Okay. So we have a sphere which is completely encloses this. Okay. So flux through this is phi naught. It will be Q total upon epsilon naught. Right? We have to find this Q total. Electric flux is another spherical surface. So we have a disk again and there is a surface such that it is of radius r by 4. So like this. So this is r by 4. So we have to find charge enclosed, only this we have to find. Okay. So let's just find the charge. It will be rho if I take r distance a ring of radius r thickness dr. So it will be simply 2 pi r dr, right? This is a simple thing, right? You have done it a lot. So it will be sigma into dA. Q will be sigma 2 pi r dr. Let's just put it here. It will be rho naught 1 minus r by capital R 2 pi r dr. So it will be rho naught 2 pi, it will be r minus r square by capital R to dr, right? So we will get Q as rho naught into 2 pi, we'll get r square by 2 minus r cube by 3r, and limit will put from 0 to anything. So in first case we'll put just r, right? So it will be rho total. In second case rho dash, we'll just put r square by 2 minus r cube by 3r, and we'll put 0 to r by 4, right? Okay, let's just get the answer. So in this case it will be rho naught 2 pi. If I put r, it will be r square by 2 minus r square by 3. So we will get rho naught 2 pi r square by 6. Now here we'll get rho naught 2 pi r by 4. So it will be 16 into. So we can take r square as common. No, don't worry. Let's just go with the flow. R square by 16 into 2, 32 minus. Okay, it will be a little bit complicated. R square by 4, 4 cube. So it will be 4 cube into 3, right? So we'll take rho naught 2 pi. R square by 16, I'm taking it common. So we'll get 1 by 2 minus 1 by 12. All right. So we are left with rho naught 2 pi r square by 16. This will be 12. So 6 minus 1. So we can cancel this 2, right? Okay, so let's leave it like that. Rho naught 2 pi r square by 16. So this was 6. Okay, into 5 by 12. Right? So we have to divide the flux. So flux phi naught by 5 will be Q total by epsilon naught upon Q dash by epsilon naught. So simply we have to divide these. So it will be rho naught 2 pi r square by 6 divided by rho naught 2 pi. What do we got? R square 5r square by 16 into 12. Okay. So it was 5r square 16 into 12. Right. So rho naught 2 pi, rho naught 2 pi, r square 6 into 2. So we will have 32 upon 5. So 32 upon 5. So it will be 6.4, right? 6.4 will be the answer. Okay. So it's an easy question again. Nothing to worry here. Okay, perfect. Let's move on to our eighth question, shall we? Eighth question. Okay, it's a little blurry. Sorry for that. One end of a spring of negligible unstretched length. So like this spring has unstretched length, something which is negligible. Spring constant K is fixed at this. Okay, this is origin. Now a point mass particle M carrying a positive charge Q is attached to the other end, and the entire system is kept on the smooth horizontal surface. Right. So this is our surface. Now what happens is when a point dipole P pointing towards the Q. So this is a dipole and it is pointing towards Q. It's fixed. The a spring gets stretched to length L, so it will stretch to a length L. This is Q. This is our Q and attains equilibrium. So if attains equilibrium, then this will be here will be KL and here will be Q into E. So we know E at axial position will be 2 upon 2K P upon L cube. Yes. So we'll write just as 2 upon 4 pi epsilon naught P upon L cube. So we will have 1 upon 4 pi epsilon naught P upon L cube, right? So if it is equilibrium, so KL must be equals to Q into P upon, so it's 2 pi epsilon naught L cube, right? So this is our first equation. Now attains equilibrium. Okay. So if the point mass is now displaced slightly, let's say it is displaced by delta L. So we'll just write it as X. Okay, why I'm writing X? Because look, in the SHM we have always, it is displaced small, it is displaced by small length, right? So we always write in terms of X because in SHM F must be proportional to minus of X, right? This is the condition of SHM. And then we can find the frequency. So we have to find frequency actually. So we have to consider it as SHM. So I'm taking as X, right? Okay, perfect. So if I'm displacing it like length X, we will have the net force here will be K L plus X, and here this E dash will change. So Q into E dash, right? So net force will be what? So K L plus X minus Q E dash. So it must be here. F net must be in this direction, right? Perfect. So write KL plus X minus Q. E dash will be what? So E dash will be this time 1 upon 2 pi epsilon naught P upon L plus X to the whole cube, right? So look, KL is this. So let's just put it here. So we'll have KX plus KL. In the place of KL, we can write Q upon 2 pi epsilon naught P upon L cube minus QP upon 2 pi epsilon naught L plus X to the whole cube, right? This is F net. So let's just solve it here. We get F net Kx minus, let's just plus QP upon 2 pi epsilon naught. We can take it as common. 1 by L cube minus 1 upon L plus X to the whole cube. Now in the question, we have taken L as delta L, right? So in the question, here we have taken delta L as X, right? And it is given X is much less than L. Okay, we have to use this condition. Let's first solve it here. We get F net Kx plus Qp upon 2 pi epsilon naught. I'm just writing it directly. L cube plus X cube plus 3L square X plus 3X square L minus L cube upon L cube into L plus X to the whole cube. Now if X is much less than X, then X square will be 0 and X cube will also be 0. So let's make it 0 and this is also 0 and L cube will get cancelled from here. So we are left with Kx qp, and L plus x to the whole cube we can just write is at like L cube, right? So we're left with qp upon 2 pi epsilon naught L cube into 3L square x by L cube. So this will be L, and now look, this qp by 2 pi epsilon naught L cube we can write it as KL. Again, let's replace it by KL. Yes, so kx plus KL into 3x divided by L. So L will get cancelled. So we will left with 4kx. Now, so this is a condition for SHM. We can just write it as mass into acceleration will be. And look, F net will be in this direction. Yes, because this is greater than this. And like when we solve it, we have considered it as a greater, and hence, and we automatically get positive. So it will be, you can write it as like this. Okay, so we have mass into acceleration will be minus, so 4k minus x. So acceleration will be 4k by m to minus x. So this is what omega square. So omega square equals to 4k by m. So omega will be 4k by m, right? Sorry. And we know frequency as omega by 2 pi, right? So we will get 1 upon pi and 2 will get cancelled. We'll get k by m. Sorry. So delta will be pi. By comparing, we'll get delta as pi. Perfect. Let's move on to our next question. So it's an easy question, but a little bit of calculation. So I'll consider it as moderate. So let's move on to our ninth question. Okay. So what we have here, a particle of mass this charge this is initially at rest at equal to 0. It comes under the influence of electric field. So this effect of force on the particle, then the maximum speed attained by the particle. Okay. So it's an easy question. Force will be Q into E, and force we can write mass into acceleration as QE, and acceleration we can write dV by dt equals to Q into E. So we just have to integrate it and solve QE dt, right? So let's just write V Q. Now E will be, it will be E naught sine omega t into dt. So if we integrate Q E naught, so it will be minus cos omega t divided by omega, right? So limit at t equal to 0, velocity is 0. It is starting from rest at p some point, right? So we will have mv equals to q epsilon naught upon omega. We'll put t minus cos omega t minus minus plus t0 cos 0. Cos 0 is 1. So we will have mv is equals to q epsilon naught, and m we can divide, right? So m we can divide m omega 1 minus cos omega t. So if we have to find the maximum velocity, then cos omega t, we have to put the minimum value of cos omega t. So cos omega t will be minus 1. Yes, so it's minimum. So V max will turns out to be 1 minus 2 q E naught upon m omega. So we will have q is 1, E naught is also 1, okay? m is 10 raised to power minus 3 and omega is 10 raised to power 3. So it will be 2 meter per second. So it's a pretty easy question we have here. Let's move on to our next question. 10th. So this is our 10th question. Right. So a solid sphere of radius RQ charge distributed in its volume as this. So density is given KRA. Center. So electric field at R by 2 is 1 upon 8 times R. So yes. So it's a similar question. We have to find Q as integration rho dV. So rho will be KRA and dV will be 4 pi R square dr. Okay. So I'm not putting limit for now. We'll get 4 pi K R 2 plus A dr. So rather than 2 plus A, we can just write A plus 2 dr. So we will get 4 pi K R to the power A plus 3 by A plus 3. Okay, Q total. So from 0 to something. So in first case, we can write 0 to R. It will be Q total. And for the second case, Q dash will be 4 pi K for R by 2, right? So R A plus 3 by A plus 3, 0 to R by 2. So for Q total, we simply get 4 pi K by A plus 3. It will be R A plus 3 by, okay, so it's just R A plus 3. Okay. Now for Q dash, it will be 4 pi K by A plus 3 and R by 2 if I put, so it will be R A plus 3 by 2 to the power A plus 3, right? Now let's find the electric field using Gauss law. So electric field into area will be 4 pi capital R square. Q enclosed will be Q total upon epsilon naught. So electric field we will get is 1 upon 4 pi R square Qt upon epsilon naught, right? And from here we will get E dash into 4 pi R by 2 whole square will be Q dash by epsilon naught. So E dash will be simply, so 4 will get cancelled, it will be simply Q dash upon pi R square epsilon naught, right? And we have given in the question E by E dash is 8. So just put those values Qt upon 4 pi epsilon naught R square upon Q dash pi R square epsilon naught will be 8. So we have pi epsilon naught R square will get cancelled. So we will left with Qt upon Q dash 4. So this will be 32, right? Okay. So let's put these values here, right? So what was Qt? Qt was 4 pi k by a plus 3 to r to the power a plus 3 and 32 we can write. Okay, so first Q dash, let's put Q dash. So it's 4 pi k upon a plus 3 and we will have r to the power a plus 3 upon 2a plus 3, right? And here we will have 32 as 32 as 2 to the power 5, right? Okay, so this is cancel, these will get cancelled, so we'll simply get 2a plus 3 is equals to 2 to the power 5. Okay, so a plus 3 is 5, so we'll get a as 2. Yes, so this is an Again, easy question. So uniform questions from uniform charge, non-uniformly charged distribution are so many in this. Okay, so be careful. This topic is very important from JEE perspective. Okay, let's move on to our 11th question. Let's move on to our 11th question. Okay, so let's match the following. Right. Okay. So in this question we have electric field is measured at a point 00 D. Okay. Due to various charge distribution and dependency E on D is found to be different for different. Right. So list one we have to match. Okay. So let's match two from one. Okay. A point charge distribution Q, we know it is proportional to 1 by D square. So for R is 1. Okay, everyone is matching. Let's check S2. S2, 4 or 5. So what is S? So 1 by dq. We know it is for the dipole. So which is dipole? So it's 2. So S2. Yes. So S2. So these options are not wrong. These are wrong. S2 R1. Okay. Q3P. So we just have to check if R has 1 and 4 both. So R is this, 1 is right, 1 will have. Let's check the 4. So fourth is what? Two infinite wires carrying a linear charge density parallel to x-axis. So let's say this is our x. This is our x. Okay, and this is our z. So they are linear charge density plus lambda and minus lambda at plus lambda is at 0 z minus l. No. So one along z plus l has a linear charge density lambda. Okay, so this is L, let's suppose. So this point will be 0 comma 0 comma L. So this is plus lambda, and here we have another. This is 0 comma 0 comma minus L. This is minus lambda. Perfect. Okay, so we have to find the electric field at D. So on the point 0 0 comma D, right? In this question it is asking. So look, in this question we have 2L is much less than D. So these are very close. So if I take any point beyond this and beyond these two wires, we'll get. So these are very close. So if I put uh, any P point here, we'll get 2k lambda by this is D here, and due to this it will be minus. So it will be this direction 2k lambda. So these will get cancelled here and here. So we just have to check in the middle. So let's say P we have here. We can check these points here, right? Okay, so let's say this is at a distance. So this is D, right? So what it will be? It will be L minus T, right? And this is L. So at this point, due to this, electric field will be in this direction, and due to this, electric field will also be in this direction. So it will be minus. So it will be E at P point will be E lambda plus E due to minus lambda. So E lambda will be, this is L plus D. So 2k lambda by L plus D plus 2k lambda by L minus D. So 2k lambda we can take it as common. We'll get L minus D plus L plus T divided by L square minus D square. So D will get cancelled. So we're left with E at P point will be 2k lambda L. So it will be 2L. So this will be 4L divided by L square minus D square. Now, as 2L is much less than D, so L square minus D square, we can just write it as minus D square. right? So it must not be L minus D. If this is D, so D is the negative, right? Oh, so we can take D is here. So if this is D, then this will be L minus D in this direction. Okay, okay. So negative is showing the direction of electric field, right? Yeah. So negative, uh, but we cannot take L square minus D square as D square because D is much greater than L. So we cannot take it like this, right? Because like in the middle we cannot take any point like this. So we cannot do like this, right? Okay, if we cannot do like this, let's just remove this. Let's solve for the point outside, right? Let's solve for the points outside. Okay, so we have these two wires. This is our x-axis. This is our z-axis. Now, this is L, this is L. Let's say D here. Okay, so this distance will be, this is 0 comma 0 comma 0. This is 0 comma 0 p point, right? So this distance will be d minus L and this distance will be d plus L. Now, so electric field at P will be in this direction due to lambda, and due to minus lambda it will be minus this direction. So EP will be E lambda minus E of minus lambda. So EP lambda will be 2k lambda by d minus L minus 2k lambda by d plus L. Okay, so from here we can solve it, right? So I have just taken a very approximate condition that these are very close and hence electric field at outside will be almost zero. So it will not be, if we calculate precisely, so it will be 2k lambda by this with d plus L minus d plus L divided by d square minus L square. Okay, so d will get cancelled here. So d will get cancelled here. We'll left with EP will be 2k lambda into 2L divided by d square minus L square. Now you can use the approximation. So d square minus L square can be written as d square itself. So we will get EP 4k lambda L by d square. So EP is inversely proportional to d square. Yes. So fourth is R for fourth is option. So B will be correct. Okay. So in the middle we cannot take, right? Because D is much greater than 12. So we cannot take any point in the middle. So we have to take the point outside these wires, right? Okay, perfect. So before this, our approximation was also correct that if these two wires are very close, then electric field outside will be approximately zero. Okay, so it will be approximately zero, but to be precise, it will be like this. Okay, let's move on to our 12th question. All right. So what we have here is a thin ring of radius 1 meter positive charge uniformly distributed over it. A particle of mass this having a negative charge is placed on an axis at a distance of 1 centimeter. Okay, so it's a simple question, I think. So its radius is 1 meter, and at a 1 centimeter, a particle is placed. So this has a total charge 1 into 10 raised to the power minus 5, and this particle has a charge 1 into 10 to the power minus 6 coulomb. Okay. Now show that the negatively charged particle is approximately SHM and calculate the time period. So yes, it will be SHM. Why? This 1 centimeter is much less than 1. So it will come out to be what? SHM, right? So let's just solve electric field at any point P at a distance x due to ring is what? Yes. Yes. So we have solved it, right? So electric field was in this direction, then we have to take the component E cos theta, right? So what was it? Yes, it was K hmm, Q total, right? Divided by this distance, right? So it was x square plus r square and then cos theta. So cos theta was base upon x square plus r square to the power 3 by 2, right? So 1 by 2. So it becomes 3 by 2. So EP will be kqt x upon x square plus r square to the power 3 by 2, right? Now as q is negatively charged, so net force will be in this direction. So force will come out to be q into kqt by x square plus r square to the power 3 by 2 into x. Now as x square plus x is much less than r, so we can write x square plus r square to be r square. So at the bottom it will become r cube. So simply force will be k q qt upon r cube into x, which is a condition for SHM, right? So let's just put the values and we can find the time period. So mass is given, so we can just write m into a will be equals to q k q qt upon r cube into x. So we will have acceleration as k q qt upon m r cube into x. So omega will be root this mr cube, and if this is omega we can write 2 pi by t. So t will come out to be 2 pi root mr cube upon k q qt, right? So it will get, let's just put the values, t equal to 2 pi, so 22 by 7 root. So m is what? M is how much? So we have m is 0.9 grams. So it will be 0.9 into 10 raised to power minus 3, and r cube is simple 1 meter, so 1 divided by k. So it is 1 upon 4 pi epsilon naught, which is 9 into 10 raised to power 9 q. Q is 10 raised to power minus 5 and 10 raised to power minus 6. So it will be 10 raised to power minus 11. So, right? Okay, perfect. So we will have, this is 10 raised to power minus 2 So this is 10 raised to power minus 1. So we're left with 2 into 22 by 7 under root 9 will get cancelled, so it is 1 upon 100. So 1 upon 10. So this into 3.14 divided by 10. So we will have 6.28 by 10. So it will 0.6 seconds. Right? So this will be our answer. So let me just check it. So it is 0.628, right? Perfect. Let's move on to our let's move on to our 13th question. Let's move on to our 13th question. So yes, a charged particle is free to move in electric field. Will it always move along the? So this is wrong. This is a basic question, right? So no. Why? Suppose we have an electric field like this and a particle is moving like this. Suppose it has a velocity in this direction. So definitely if it has a charge Q, force will come in this direction. It will start to bend towards this F, but it will move like this. Electric field is like this, the particle trajectory will be like this. So this is no, it is not always move like this, right? So this was our 13th question. Let's move on to 14th question. Right. So a pendulum of bore mass this carrying a charge this is at rest in the horizontal uniform electric field. Okay, so electric field is like this and the pendulum is like this. Okay, so it will make some angle theta, right? Find the tension. So it's an easy question, basic. T downward will be mg and QE will be here. So this is theta. So T cos theta will be balancing mg and T sin theta will be balancing QE, right? An angle we have to find. So T cos theta will be equals to mg. So m will be 80 milligram. So 80 into 10 is to power minus 6 kg will be, okay? Into g is 9.8. So this is our T, and T sin theta will be QE. Q is 2 into 10 raised to power minus 8, and electric field is this 20,000. Okay, now to find T we can just square and add them. So T square will be, so this will turn out to be, if I calculate it fast, so we have, so 9.8 into 9.8 into 80. So it will be, it will be 9.8 into 80. So it will be 784 into 10 is to power minus 6. So we will get 7.84 into 10 is to power minus 4, right? And this will get 1, 2, 3, 4. So it will be 4 into 10 is to power minus 4. Okay. So if I square and add them, so we will have 10 is to power minus 8 and 7.84 into 7.84. It will be 61.4656 plus 16, right? So T will be 10 is to power minus 4 root this. So it will be 77.4. 4656. So root 77.4656 will get 8.8. So it will be 8.8 into 10 raised to power minus 4 newtons. So if I get tension, we can find theta as well, right? Okay. So tension is this. Simply you can find the theta. Okay. So it's an easy question. Let's move on to the 15th question. So right. Okay. So we have a charge Q surrounded by a closed surface consisting of inverted cone and a hemisphere this. So electric flux through the conical surface. Okay, perfect. So look, if there is any closed surface, the total flux will be Q upon epsilon naught, right? And if we know due to hemisphere, the flux will be due to hemisphere will be it will be Q upon 2 epsilon naught. Now you can add any type of surface, it will be other half. So from cone, it will be other half of the flux. It will be Q upon 2 epsilon naught itself, right? So simple and turns out to be 3, right? So and turns out to be 3. So it's a very simple question. It's a pretty basic question. Now let's move on to our final three questions, which are true, false. So 16th, 17th, and 18th. Okay. So right. Now the first. R carries a charge Q uniformly ring R and placed. Okay, so if we have this situation, this is a ring of radius R and this is a distance 2R, right? And we have a charge here minus Q. So released from the rest, the particle execute SHM. No, look, the condition for SHM we have just derived it. This X must be very small. Then we can use this approximation. We have just solved this question. Uh, what is it? Here? Yes, right. So we have used this when X is much less than R. Otherwise, we couldn't have solved this. Okay, simple. It will be no. So this is false, right? Next. Electric line of force is like this: a particle with unit positive charge initially at rest. Okay, so we have electric field in this circle only. There is no inside, there is no outside. Particle is here, so it's y-axis. So it's x. This is y, and the particle is here on this part, right? It has charge q. Will move along the line of force. No, circular line. No, of course not. Look, if it is here, even though it reaches here, the force will act in this direction along this, but the velocity will be here, right? So it will move like this and it will go like this, right? And to move its circular motion, we must have a centripetal acceleration. So there is no force which is providing this centripetal acceleration. So this is also false, right? Now, a small metal ball is suspended in uniform electric field with the help of insulated thread. Okay, X-rays. So X-ray beam falls on the ball, right? So what will happen if X-ray falls on the ball? Yes. So X-ray have very high energy. So what will happen? Electron will ejected from it. Okay. So if electron will ejected, this will have positive charge. Sphere will have positive charge. And if electric field in this direction, then positive charge deflect in the direction of electric field. So ball will be deflected in the direction of electric field. So this is true. Okay. So pretty easy question we have discussed, nothing more. But there is some question from flux which are very good. Okay, so please be, and there are questions of non-uniformly charged distribution. Okay, so these questions are very important from JEE perspective. Let's finish the today's video. So bye bye everyone.